Today we bring you the third video in the History of Supernova Discoveries series. If you have not watched the previous videos in the History of Supernova Discoveries video series, we invite you to watch them before watching this video. Those videos are in the playlist 16 History of Supernova Discoveries. Also, in the description of this video, there are links to previous videos. We invite you to stay until the last moment of this video. The early decades of the 20th century W1 TNES transformat 1VE advancements 1N supernova astronomy, largely due to the P11 running work of AMER 1 astronomer Walter Baade and SW1SS, AMER 1 astronomer FR1 TZZW1 CKY. 1 in 1934, they formally introduced the term supernova. To D1 SD1 GU1SH, these extraord 1 NAR 1 LY LUM 1 new stellar explodes 1 ons from less energit 1 C nova events. TH1S term 1 Nalag 1 Cal Clar 1 Tai reflected grow 1ing SC1 Ent 1 F1 C understand 1ing of the vast energy D1 differences between these phenomena. Der 1ing TH1S per 1 OD. ZW1CKY1N1T1 aided system at 1C supernova searches us 1ing the 18-1NCHSCHM1DT telescope at Palomar Observatory. Dramat 1 Cali 1 Krias 1ing the rate of supernova D1 Scover 1 ES beyond the M1 Lake UA. A CR1T1 Cal conceptual breakthrough came when Baade and ZW1CKY proposed that supernovae represent the trans 1T1 on of ordinary stars 1 to neutron stars. 1 cred 1 Bly dense objects, composed almost ent 1 rely of neutrons. TH1S Presk 1 N hypotheses 1S. Made years before the Observat 1 Onal CO1F 1 Ramat 1 on of neutron stars. Correctly 1 Dent 1 F1 Ed 1 of the potent 1 Al N states for mass 1 VE stars. The 1 are work a stable 1 shed that supernovae release energy EC 1 valent to the converse 1 on of S1 GN 1 F1 cant stellar mass 1 to rad 1 at 1 on. Explo 1 N 1ing the 1 are extraord 1 nary lum 1 nos 1 tie. The development of spectroscope 1 C Techn 1 Ks der 1ing TH1S era enabled astronomers to analyze the Chem 1 Cal compass 1 T1 on of supernova explodes 1 ons, reveal 1ing Kruk 1 Al 1 format 1 on about nucleosynthesis 1S, the Crete 1 on of heavy elements through stellar processes. By the 1940s, Rudolf M1 Kausk 1 had begun class 1 FY1ing supernovae based on the 1 R spectral character 1 SD1CS, D1B1 D1ing them 1 to 2 broad category 1 ES. Type 1, lack 1ing hydrogen L1S, and Type 2, show 1ing hydrogen L1S. TH1S1N1T1 out class 1F1 Cat 1 on system La 1D the groundwork for the more Ref 1 Ned category 1s at 1 on schemes that would emerge 1 and subsequent decades. The Grow 1ing catalog of extragalact 1C supernovae der 1ing TH1S per 1 OD also enabled astronomers to recone 1ZE, the 1 are potent 1 Al, as standard candles for Measur 1 Ingsusum 1 CD 1 stances. And 1 NS1 GHD that would eventually revel at 1 on 1ZE cosmology through the work of researchers study 1ing type 1A supernovae 1 N the late 20th century. The M1D 20th century saw RAP 1D accelerat 1 on 1 N supernova research. FAC 1 L1 tated by Technolog 1 Cal advancements 1 N astronom 1 Cal 1 instrumentat 1 on and comput 1ing. The development of larger telescopes, 1 proved photograph 1C Techn 1Ks, and eventually electron 1C detect 1 on systems Dramat 1 Cali enhanced astronomers of 1 L1 tie to D1 Scover and character 1ZE supernovae. 1 in 1968, astronomers D1 discovered the Vela pulsar W1 TH1 and the Vela supernova remnant. Prov 1 D1ing compel 1ing Observat 1 Onal Ev 1 Denke support 1ing the Baade. ZW1CKY hypotheses 1S that neutron stars formed der 1ing supernova explodes 1 ons. TH1S D1 discovery. Com 1ing shortly after Jocelyn Bell Burnell's 1 Dent 1 F1 Cat 1 on of the F1 RST pulsar 1 N 1967. CONF1 remed the Theoret 1 Cal L1 in K between supernovae and these RAP 1 delay rotat 1ing neutron stars. The Ref 1 element of supernova class 1F1 Cat 1 on Cont 1 Nu der 1ing TH1S per 1 OD, W1th astronomers recon 1Z1ing 1 portent sub 1V1S1 ons W1th1 and the, or 1G1 NAL type 1, and type 2 category 1ES. By the 1980s, researchers had 1 dent 1F1 ed type 1A 1B, and 1 C-class 1F1 cat 1 ons based on spectral D1 differences, reflect 1ing D1 SD1 NCT Pro Gen 1 Tor systems, and explos 1 on Mechan 1 SMS. Type 1A supernovae. Character 1Z by S1L1 con absorbed 1 on L1S and the absence of hydrogen, where 1 dent 1 F1 ed, as thermonuclear explos 1 ons 1 NB1 nary systems, 1 vol 1 ing WH1T dwarfs. 1N contrast, types 1B, 1C, and 2 were recon 1Z as core collapse events occur 1ing 1N mass 1VE stars that had exhausted the 1 are nuclear fuel. A def 1N 1ing moment 1N modern supernova astronomy came W1th the Observat 1 on of SN 1987A, a supernova that appeared 1N, the Large Magellan 1C cloud, a Satel 1T galaxy of the M1 Lakey Way, on February 23, 1987. As the closest observed supernova S1 NCE Kepler's 1N1604, SN 1987A proved 1 dead unprecedented Observat 1 onal Dita 1L. Remarkably, Neutra 1 no detectors on Earth Reg 1 steered a burst of Neutra 1 nos from TH1S explos 1 on several hours before 1 TSB1S1 BLE L1 GHD reached Earth. CO1F1RM, 1ing Theoret 1 Cal Pred 1 CT 1 ons about the role of Neutra 1 nos 1 N carry 1ing away energy der 1ing stellar collapse. The extends 1V multiple 1 wavelength Observat 1 ons of SN 1987A's Evolet 1 on over subsequent decades have proved 1 dead 1 valuable data for Ref 1 N1 ing supernova models. The late 20th century W1 Tnest a Revelet 1 Onery APPL 1 Cat 1 on of supernova SC1 insta fundamental cosmolog 1 Cal Quest 1 ons. 1 in the 1990s. 2 independent research teams, the Supernova Cosmology Project, led by Saul Perlmutter, and the H1GH Z Supernova Search Team, led by BR1 and SCHM1DT and Atom R1S, began us 1ing Type 1A supernovae as standard 1 Zobel candles to measure SM1CD1 stances W1th unprecedented Prec 1S1 on. These supernovae X1B1T remarkably cons, 1 stent lum 1 nos 1 type propert 1ES, when Serta 1N correct 1 ons are APPL 1 ed. Mac 1ing them excellence sem 1 CD 1 stance 1 ND 1 K-doors. The startle 1ing D1 discovery announced by both teams 1 in 1998 revealed that D1 stant type 1A supernovae appeared D1 mer than expected based on then current cosmolog 1 Cal models. TH1S Observat 1 on led to the Revelet 1 Onery, Conclus 1, on at the expands 1 on of the un 1 verse 1's accelerat 1ing rather than slow 1ing down as previous 1 usly assumed. TH1S SM1C accelerat 1 on Rec 1 read the X1 stents of a Mr. 1S dark energy that counteracts grav 1 tie at the largest scales a D1 discovery that fundamentally altered our understand 1ing of the un 1 versus compass 1 T1 on and fate. The researchers responds 1 BLE for TH1S Parad 1 GM SH1 FT1ing work were awarded the 2011 Nobel PR 1Z 1N Phys 1 CS underscore 1ing the profound 1 impact of supernova research on fundamental phys 1 CS. The early 21st century has seen the advent of automated sky surveys, Spec 1F 1 Cali, de 1 NED to D1 Scover, supernovae 1N unprecedented numbers. Projects L1 could the Sloan D1G1 Tal Sky Survey, Pan-STARRS, and the Dark Energy Survey have detected thousands of supernovae, Crete 1ing vast datasets that enable Stat 1 SD1 Cal approaches to supernova research. These surveys have uncovered rare and exot 1C supernova types. 1 Clud 1ing superlum 1 new supernovae that ouch 1 NETYP 1 Cal events by factors of 10 to 100. And unusual trans 1 ENTs that challenge X1 SD1 in class 1F1 Cat 1 on schemes. The 1 Kriya's 1ing sample S1ZE has also enabled researchers to connect supernova Propert 1ES to the 1 our host galaxy ENV1 Ramets, Prov 1D1 ing 1 NS1 GHTS12 House Stellar Evolet 1 Onvar 1 ES across SIM 1 CT 1 Me and space. The deployment of space-based observator 1ES has DRAMIT 1 Cali expanded supernova research capab 1L1T1ES by enable 1ing observat 1 ons across the electromagnet 1C spectrum W1000 atmosphere 1C 1 interference. Satel 1 TES L1 Co the Hubble Space Telescope, Chandra X-ray Observatory, and Firm 1 Gamma Ray Space Telescope have proved 1 dead unprecedented V1 use of supernova processes at multiple 1 PLE wavelengths. These multiple 1 messenger observat 1 ons reveal D1 ferrant aspects of the explos 1 on Phys 1CS, from the 1N1T1 AL shock breakout to the format 1 on and evolut 1 on of remnants. The James Webb Space Telescope JWST represents the newest front 1 or 1N supernova research. W1TH1TS1 Frerd Capab 1 L1T1ES enable 1ing detect 1 on of the most D1 stant, and therefore Earl 1S supernovae 1N SEM 1CH1 story. 1 in January 2025, astronomers announced the D1 discovery of supernova at 2023 ADSVUS 1ing JWST. An explos 1 on that occurred approximate 1 mately 11 point for B1 LL1 on years ago, merely 2 B1 LL1 on years after the B1G bang. TH1S supernova, detected as part of the JWST Advanced Deep Extragalactic 1C Survey JADES program, appears to have been extraord 1 NAR 1 LY Energit 1C. A truly gargantuan, explos 1 on result 1ing from the death of a stellar monster approximate 1 mately 20 T1 MES, the mass of our Sun. Such observat 1 ons of early SOSM 1C supernovae prov 1 to Kruk 1 AL 1 and S1 GHTS 1 to the F1 RST GeneRat 1 ons of stars. WH1CH fundamentally D1 furred from modern stellar populate 1 ons 1 and the 1 are mass, compass 1 T1 on, and explos 1V character 1 SD 1CS. The D1 discovery of supernovae from the UN1 versus F1 RST, B1 LL1 on years, 1's part 1 cularly S1 GN1 F1 can't for understand 1ing 1C Chem 1 Cal evolut 1 on. The Earl 1S stars formed from PR, 1 Mord 1 Al Mater 1 Al Cons, 1 SD 1 ing almost ent 1 rely of hydrogen, and Hel 1 through FUS 1 on processes der 1ing the 1 are L1VS, and explos 1V nucleosynthesis 1 ester 1ing the 1 are deaths as supernovae. These stars manufactured heave 1 elements, and D1 spurs them 1 to the 1 interstellar med 1 TH1S progress 1VE ENR 1 schment of the cosmos W1TH metals, elements heave 1 earth and Hel 1 transformed star format 1 on processes, and enabled the eventual development of rocky planets, and B1 Olig 1 Cal L1 Fe. By study 1ing ANC 1N supernovae L1 Ku at 2023 ADSV, astronomers GA1 ND1 Rect observat 1 Onal Ev 1 Denke of TH1S Kruk 1 LSOSM 1C ENR 1 Schment process at 1 TS Earl 1S stages. You have just watched the last video in the History of Supernova Discoveries video series. You can see more valuable videos by clicking on the card shown here. If you want to see our next video as soon as it comes out, subscribe to our YouTube channel and click the bell icon. Thank you very much for watching the video till now.